Okay, so we're going to be solving these differential equations. And so the first step on all of these is to separate the variables. So you guys have a very small margin. I have a huge margin, but I want you guys to write that step 1 is to separate the variables. All right, so let's see how y'all did. Well, some of these are easier than others, and that's just the way it is with differential equations. And when we solve them, some of them are definitely easier than others. This one's not too terrible. What did you guys get?
dy times y equals sine of x times dx.
Good. So you're basically on this one just cross multiplying. So you do want to write the dy and the dx second. So you want to write it after the e to the x or e to the y and the sine of x. Very nice. All right, let's skip to example 2. What did you guys get for this one? Y dy, e to the x dx. Okay. Starts getting a little more challenging on this one. I'm going to leave the -2 on the top. So if you didn't do that, it's okay. It'll be all right. I just want you to fix it. It's just going to make it easier for us if we move the y without moving the -2, and it's fine. Okay, so if you leave that -2 up there, what do you guys have? dy divided by y squared. Did y'all have that? Okay, just leave the -2 up there on the top. All right, the x would technically stay right where it is also, and then you're going to multiply by dx. All right, so if you didn't get this one, I wrote it kind of lopsided, but if you didn't get this one, go ahead and straighten it out. Now, we could still make this problem work if we move that -2, so it's not wrong if you did it. It's just going to make it easier for us if we don't move it in the end.
So you got like dy over -2y squared.
It's still technically right, yes, but leaving the -2 will make it easier. Okay, this one is the one I thought was the most challenging. So we have to find a way to separate the y's from the x's. So this is going to be a multiple step separation. So how can you do that? How can you separate the y's? Factor out the y. Now we are not factoring out a common factor, and you may have. If you did factor out a common factor, let's undo that and only factor out the y. Okay. So now I need to, you guys tell me, what do I need to do now to separate the variables? What do I do with the y? Divide by the y, multiply by the dx. Okay, so that should be that one separated. All right, so that's the first step, and that's kind of a big step. Do you all have a question? Now, even if you factored that out, and only divided by the y, that's fine, but you would want to multiply it back out at some point. All right, let's talk about our second step. The second step has to be something that was a very algebra-like step. Our second step is a calculus step. So we've only done a couple of different things in calculus. And this is a differential equation, and we want to change it to just y equals. We don't want a derivative anymore. So what do you guys think we need to do? Integrate it or find the antiderivative. All right, so that's our calculus step in this whole process. And then the last step, we're moving back to an algebra step. And it is to solve for y. All right, so it's a 3-step process. And again, like I said, sometimes it's quick and not very painful. And then sometimes it gets pretty complicated. All right, and then today we're doing the general equations. So we'll have the plus C and all that. Tomorrow we're gonna find a specific equation that goes through a certain point. So tomorrow we'll have a little extra steps in it. All right, so let's look at example 1. Once we have it separated, we're ready to integrate. So what I want you guys to do is when you find the antiderivative or you're doing the integral, I want you to draw the symbol for me, please. So the person grading your AP test knows what you did, that you didn't just do something without telling them. So what is the antiderivative of e to the y dy? E to the y plus c. I'm going to hold off on my plus c for just a second. I'm going to write it and then, no, I'm not going to write it. We're not going to do the plus c on the left. I'll explain why in just a second. All right, what about the antiderivative of sine of x dx? Negative cosine of x plus c. Okay, now we can do plus c on both sides, but if I do, and then I get my constants together, that's just going to give me another constant. Does that make sense? So it's we only have to do it on one side. Now, if you did it on both sides and then you get them together, it's still going to be just a plus c. When you add constants or subtract constants, you get another constant. All right, now we want to solve this for y. How do we get an exponent down? Good. So we're going to take the natural log of both sides. Okay, and then the natural log of e to the y is just y. So that is our equation, the general equation that matches this differential equation.
Is this the circle thing when you go to circle or whatever? Can it be like
This one, I don't think this one would be a circle, but the natural log of the we could look at it. It might be. I'm just going to have my c be 0 on my graph. This is what it looks like. Then if I had c be something else, it would change it slightly.
tell me that thing where you like when you're solving for like natural logs and stuff
Yeah?
and you go into like a circle with it, you know? So it's like
Oh, the loop. Yeah. Yeah, I get what you're saying now. I'm sorry. I thought you were talking about the graph. Maybe. But what I do, like, if you want to bring down an exponent, you have to use a logarithm. But yeah, it's the same idea. Gotcha. Okay, let's look at the next one. All right, so we can go ahead and find the antiderivative. So make sure you show everybody what you're doing. All right, so you find each of these antiderivatives for me, please. All right, did y'all get what I got? Good, okay. Now we want to solve this for y. What would y'all do? Multiply by 2. So c is some constant. Oops. If I multiply some constant by 2, am I still going to have a constant? Is it going to be a different constant? Yes. So what I'm still going to call it c, but every time it changes to a different constant, I'm going to give it a different subscript. Now, I honestly don't know how important this is to the people who grade the AP test. They most likely will put a differential equation to solve on the free response part. There's lots and lots of them on there over the years. And I just don't know if they take off points if you don't say that the constant changed to a different constant. So I just get in the habit of, if I multiply it by something or divide it by something or change it to a negative or something, I just say it's a different constant. Okay, what would I do now? Take the square root. All right, and we're going to do the positive and negative square root. And that should be it.
You think it'll count off if you don't put positive and negative?
Well, maybe. We're going to talk a lot more about this tomorrow. When this goes to a certain point, it will either be the positive square root or the negative square root, depending on where the point is. So most likely it will have to be one or the other, and they will take off if you don't use the right one. But again, we're going to talk more about this tomorrow.
If you put positive and negative and don't differentiate which one it is.
What does that mean?
Like if you like don't choose between plus one or the plus or the negative.
If it goes through a certain point and you don't put just what it is, yeah. You'll get credit for your work, but you won't get credit for the answer. Don't stress out about it. It's going to be fine. Don't worry.
Don't know about it.
We'll talk about it tomorrow. I'm just giving y'all like a sneak peek. Okay, so on this one, before I do the antiderivative, what do I need to do? Can I do it the way it's written right now? I mean, I guess I could. Yeah, I would probably rewrite this as y to the negative 2 dy and negative 2x to the negative 2 dx. Now, if you can think ahead several steps and do it when it's written the other way, then that's fine. But I need to see the exponents. All right, so now we're ready to find the antiderivative. So we're going to add 1 to negative 2 and divide by that. And that is also our new exponent. Same thing on the other side. Add 1 to negative 2 and divide by that. And it is our new exponent. Okay, so we need to solve this for y. So I'm going to take care of that negative in the front. Actually, let's just wait. All right, let's write this as negative 1 over y. Okay, and then this is going to be 2 over x plus c. All right, now what I want, so I can, because this is 1 over y, we want y. I'm actually going to write this side also as a fraction, the right side. So to write this just as one fraction, where I don't have a fraction plus c, what do I need to do with this c? Right, we want to make it have a common denominator, and that common denominator is going to be x. All right, this is kind of weird. So what we have is x on the denominator, and then 2 plus c times x on the numerator. Yay! Thank you. All right, then at this point, if we wanted to go through all the math, we would cross multiply. And I'm going to write what we would get, but then I'm going to show you a shorter way to do it. So we would cross multiply. And then solve for y. To solve for y, we would divide. Thank you. So if you're looking at what we had before and what we will end up getting, is there a quicker way to do it? Just flip them both over, right? Huh?
Just flip them first.
Yeah, just flip them both over. All right, and then take care of that negative. All right, so you guys can do that. If you end up with 1 over y equals something, as long as it's just one thing, it's not a fraction plus c, then you can just flip them both over and you're done. Okay, so look at that for a second. We did some kind of crazy algebra. Is there a part of it that you're not really sure about? Now this right here is not something we did in algebra very much. Or I didn't in my algebra classes. Okay, we have one more. It's gonna be fun. Y'all ready? Now for this dy over y, do I need to rewrite that as y to the negative 1 to find the antiderivative? No. What is the antiderivative of dy over y? The natural log of the absolute value of y. All right, for the second one, I'm going to do the power rule for antiderivatives. All right, so now I want to solve this logarithmic equation for y. How do you get rid of a natural log? Raise it, do the e, raise it to, or e raised to it. So exponentiate is what it's typically called. I like to call it raising the base, but it's going to be e raised to the natural log of the absolute value of y equals e raised to all this stuff. Right, now the reason we do that is because on the left side, that's just going to leave us with the absolute value of y. On the right side, we're going to do some more semi-crazy algebra. So I'm going to come over to this side. You guys do not have to write this down. If we had e to the x times e to the second, you're multiplying, they have the same base. What do you do with those exponents? You add them. So it's going to be e to the x plus 2. We're going to undo that addition. Okay, so let's say instead we have e to the 2x plus 4. We want to undo the addition and change it to multiplication. What would it change to? E to the 2x times e to the 4. That's what we're going to have to do here. Okay, so I'm going to leave the ones with the x's alone. So this is going to equal e to the x to the 4th minus 2x to the 3rd. All right, and then we're going to multiply that by e to the c. Y'all okay? Okay, so when we're about to do it right now, actually. So when you do something to the constant from the original, that changes it to a different constant. That's the only time you have to do it. We've only had to do that one time so far, and that's when I multiplied a constant by 2, so I just said that was a different constant. All right, so let's talk about e to the c for a second. So e is about 2.7818. If I took e and I raised it to a constant, let's just say the 3rd, I get another constant, right? So this e to the 2nd is a constant. That's different from the original constant, and it's being multiplied by it. So I'm going to call that e or c sub 1 e to the 4, to the x to the 4th minus 2x to the 3rd. There's a whole bunch of the raised to the in this problem. All right, so this right here became a different constant that's being multiplied by the e. That's kind of weird. All right, one more thing, and this is the algebra thing. Solve an absolute value equation. What do?
What's it?
You have two, right, with a plus and a minus. So this is going to be positive and negative, c to the 1, e to the x raised to the 4th minus 2x raised to the 3rd. And again, if we're finding this for a specific value, it would only be either the plus or the minus. I know, this is a lot. Okay. Do you guys have any questions before I stop recording?